Finally, for the setup, we want to record some histories. I have here probably more histories than we need. To get the frequency, we want to see the oscillation of the potential or the electric field in these cavities. We will by default be able to see a spatial function of these in the visualization. So these histories are for something extra, like if we want to time trace at a particular point. For this, it would be sufficient to just pick a point in one of the cavities and look at the time trace of that. So to do that, you would just right-click on History, you would add a field history, and then you can choose what you want to look at. In this case, we want to know the pseudopotential. So you can add those, and we can see here, these are pseudopotentials at a coordinate, and then you just pick the coordinate that is in the place you want to look. We have all these histories, so we can look at a bunch of different places. All right, now we're all set up. So let's run the simulation and see what happens. So we made some changes. It'll ask us to save. So we do. We go up here and make sure that everything is as it should be. We notice here that the time step matches the number of steps. We don't have a dump periodicity. So actually, let's go back to our setups and go to basic settings. And this is where you set the basic settings of the simulation. In this case, our dmfrac, our CFL number, the DT. Now, some of these we'll need to adjust manually. So the number of steps, well, we made a parameter for that. So we can go to the in steps to excite. It says over 10,000 we need, just about 11,000. So we'll go to basic settings. We want to make sure we do at least what it says. So 11,000. We don't need a lot of dumps. We're not looking for anything too specific during the excite phase. So I'm just going to put 5,000. So it'll dump every 5,000 steps. And that's good enough. So now we will save and set up. We will go to run, reset the setup values, put this in manually. We said 5,000. We're going to dump it the first time step. We're going to run in parallel, make it as fast as we can, and let's hit go. This is a pretty quick simulation. Our resolution is not super high, so we finish very quickly. Now we can go ahead and just look at this and see what it looks like right now. We hit visualize here on the left. It loads in the HDF5 files. And now let's take a look at the Z component of the electric field. Right now this doesn't look like much. We're going to go to the plane controls. Well, first I can left click and rotate this, and you can see it's just a solid blue box. And the reason that is because we need to slice it. So I'm going to take an X slice, and that'll cut the domain but at 0. So now, if I also turn on our geometry, you can see the outline of the cavity here. And then we can move through our dumps and see the electric field as we excite. That's not super exciting just yet, but it's doing something like we'd expect. We see oscillating red and blue. If we go to the histories, that's more interesting. We can see what we expected. At some point, our current ramped up, and then our electric field stayed pretty high from that point after we hit some resonant mode. And it's the frequency of this mode that we care about. Now I can do something simple here, like click this FFT button, and we'll get a peak. And that peak will give us a rough idea of the frequency of our cavity. Now you can see all these wiggles, and these are because it's FFTing the entire time signal, which included this ramp up phase. But the peak is right around where we would expect, 1.51, 1.52 gigahertz.